Hi, everybody. Well, as everybody's beginning to join and coming in, I'm going to start today's research bites, and I'm really happy to welcome Elaine, who is going to talk about her research on metabotypes. So Elaine is a final year student in the School of Agriculture and Food Science, and she started her career as a degree in nutrition, and then went on to train in dietetics and worked for a few years as a dietitian. She has a master's MSc from the University of São Paulo, and then following award of a scholarship has come to pursue her PhD with us here in UCD. She joined Lorraine's group and has been working on metabotypes and personalized nutrition. And as I said, she's in her final year. She's been publishing papers in high impact journals and has won awards for both her papers and her posters and presentations throughout her PhD career. So today we're going to hear metabotypes, what's their potential in nutrition research. So I'll hand over to you, Elaine. Just want to remind everybody to keep their microphones muted, and then we'll do questions and answers at the end. Okay, thanks, Elaine.
Okay, thank you, Eileen, for your introduction and for the opportunity to present my research here. And good morning, everyone. So in this presentation, I'm going to discuss the potential of metabotypes in nutrition research and also the work that has been developed as part of my PhD. So here on the left side, we have what we usually do in nutrition. So the most common approaches to deliver dietary advice are based on the population level, what we know as the one-size-fits-all generic advice. But unfortunately, these interventions have shown a limited impact on well-being and health outcomes. So a more effective approach is personalized nutrition, what is usually described as dietary advice tailored at an individual level. So regarding the personalization of the advice, this can be done using a variety of factors. So the behavioral factors can include individual dietary intake, physical activity level, individual preferences. Also the objectives, personal objectives can be included. And of course, the biological characteristics such as response to foods and nutrients, and phenotype that can comprise anthropometry, blood information, and genomic profile. But in the end, the goal of personalized nutrition is the same, that is to support individuals in sustainable change in dietary behavior, what will ultimately to have a positive impact on health outcomes. So we have considerable body of evidence showing that personalized nutrition is more effective to make positive change in dietary behavior. So this systematic review was recently published and reported that 8 of 11 studies improved dietary intake in a greater extent in participants receiving personalized nutrition compared to those that receive the generic advice, and this with a low risk of bias. So, but personalized nutrition can be delivered using many different approaches. For example, this work from Zevi and collaborators, they developed an algorithm to predict postprandial glucose response. So they used data on microbiome, blood information, lifestyle questionnaires, anthropometry to train algorithm to predict glucose response. And then this algorithm was validated in a smaller cohort of participants. The actual glucose response from these individuals in this study was compared to the values predicted by the algorithm here at the bottom, and to the values that were predicted by standard methods at the top. And here we see that the algorithm was better, performed better to predict glucose response. And then this model was then applied to an intervention study where one study arm received personalized dietary advice based on the algorithm, and the other arm of the study received advice from experts. So both arms received some type of personalized advice. All individuals in this study, they were put on a bad diet, here represented by the red color, and a good diet in the green color. But each diet according to their group. So this graph shows the maximum postprandial glucose response to these diets. And what we have is actually a similar result between groups, between the predictor group and the expert group. However, the advantage of this algorithm is that it is like an automated process. And this is another study from this group. Actually, it's very recent. It's just out about this algorithm. So the algorithm was compared to the Mediterranean diet in a 6-month intervention study, and it performed better to reduce and control the levels of glucose. So with these results, and then these results, they were sustained at month 12. So this shows the long-term impact of this approach. But this study is based only on one aspect of the diet, that's to control the glucose levels, and more holistic approaches were investigated. So these are the results from the Food for Me study. The Food for Me was a 6-month randomized controlled trial that deliver personalized dietary advice, considering diet intake, phenotypic, and genetic information. And this study showed that personalized nutrition was more effective than generic advice to improve intake of foods and nutrients. So in the right side, we have the chance in the personalized group, and in the left side, we have the chance in the control group. So participants in the personalized group presented a greater reduction in the intake of salt, energy, saturated fat, and red meat. And also they increased more the intake of folate and improved the diet quality. So recently, more data from this study was published comparing the intake of discretionary foods and beverages following the intervention. And after the intervention, the percentage of energy, total fat, saturated fat, and sugars from these foods and beverages was lower in the personalized group compared to the control group. So although we have these very good results with personalized nutrition at an individual level, these can be quite demanding and costly and not easily achievable in a public health scenario. So metabotypes have been suggested as a potential tool to account for biological characteristics in personalized healthcare and an option to deliver personalized nutrition, but this at a group level. So metabotypes are groups of individuals. They are defined based on their similarities in the metabolic profile, which can result from extensive interaction between diet, microbiome, environment, lifestyle, genes. And they are usually defined using clustering methods like k-means cluster analysis, hierarchical cluster analysis. And we conducted a literature review on the use of metabotypes in nutrition research with a focus on their potential to deliver personalized nutrition. And we identified 3 groups of studies. So first group, in longitudinal studies, metabotypes were associated with cardiometabolic risk factors with diet-related diseases. So metabotypes could be used in early risk identification. A second group of studies, in this group, metabotypes were used to identify differential response to intervention. And finally, the use of metabotypes to deliver nutrition is a very important area for future development. Okay, so from here, I will show some examples of each application of these studies, these groups of studies, metabotypes. And this study is from our group an example of differential response to a dietary challenge. So in this study, the individuals were grouped according to their glucose response to an oral glucose tolerance test. And 4 clusters were identified, each one represented by these lines. And one specific cluster with the one here with more impaired glucose response, this upper curve, also showed impaired a larger curve for C-peptide and insulin levels that were not restored to the baseline values. So this group was characterized, classified as a at-risk cluster because it also had the highest BMI, triglyceride, C-reactive protein, reduced beta cell function. And okay, so in this group, in this study, the individuals were classified based on their glucose response curves, and an at-risk metabotype was revealed. So this example clearly shows how metabotype could be very useful to categorize individuals according to their responses, and then like to these groups that could benefit from specific dietary interventions. And yeah, this is another study. It's an example of early risk identification. So this study aimed to identify subtypes of type 2 diabetes that could predict diabetes complication. So with 6 markers, participants, the patients were classified into 5 groups. So, and this study is particularly interesting because like they used only a few markers that are very easy to measure in a clinical setting, such as like BMI, age, insulin resistance, antibody associated to diabetes. So these 6 markers here to identify these subtypes of diabetes. And one of the groups, the green arrow, was characterized by severe insulin resistance. And when this model was applied to predict kidney disease in 2 different cohorts, this group with severe insulin resistance was the one with the highest incidence of kidney disease in both groups. This is a different study. It's still about risk stratification, but with individuals that were considered healthy in order to identify the elevated risk for the development of type 2 diabetes. And in this study, 6 metabotypes each one represented by these radar plots, they were identified and then replicated in a different cohort. So in the follow-up of these cohorts, the model was indeed able to predict the progression of the individuals to diabetes. So 2 metabotypes, the one with this green line and the other with the blue line, were the metabotypes with the highest incidence of diabetes. And the one with the green line was also the metabotype with the highest incidence of renal vascular disease or cause mortality. And here again, with these 2 examples of risk stratification, we can see that metabotypes can be very informative regarding the groups that could benefit from more focused intervention, maybe to avoid or at least to delay the progression of diseases. And for this final example, I will show you how metabotypes could be used to deliver personalized dietary advice. So our previous work developed a framework to deliver dietary advice based on metabotypes. So 3 metabotypes were defined in a cohort of adults in Ireland using K-means cluster analysis and 4 markers of metabolic health. So metabotype 1 was characterized by high total cholesterol. Metabotype 2 had all the 4 markers in a normal range. And metabotype 3 was characterized by high total cholesterol, high triglyceride, and high glucose. And for each one of these metabotypes, decision tree was developed with additional information on BMI, waist circumference, and blood pressure. So recently we updated the advice delivered by this metabotype approach with incorporation of some new messages to make sure that it comprised the recent guidelines for the management of chronic disease and also some nutrient recommendations. And with this update process, we found that the dietary messages from the metabotype approach are comparable to individualized advice. Okay, so we have this model that was developed in Ireland with the 3 metabotypes, and we did a work in collaboration with some researchers from the Helmholtz Center in Germany. And we showed that this metabotype is reproducible in a different population, since we used data from a German cohort to reproduce these metabotypes, and they fitted really well. And so this German cohort, they have a follow-up, and a 7 years follow-up. We saw that metabotype 3 had the highest incidence of metabolic and cardiovascular disease. And in addition, these metabotypes, they showed distinct intakes of foods and food groups. So these results, they strongly support our metabotype approach as a tool for risk stratification and for which dietary device could be designed and delivered for prevention. So with this example of using metabotypes to deliver dietary device, we see that the metabotype concept is actually very promising in nutrition. It seems that we could really translate this information from the metabotypes to practical advice. Besides that, it's important to highlight that this metabotype approach uses variables that we can easily measure in a clinical setting. And also how it's designed with the use of decision tree allows the automation of the process and the delivery of advice for example, the patients that are not high priority in dietary care or who don't have access to a dietitian. Okay, so, and now I will talk a bit more about our very recent work on metabotypes. So although the metabotype approach, this approach that we have is very promising to deliver dietary device, its effectiveness has never been tested in an intervention scenario. So we are currently working on an intervention study to examine the effectiveness of dietary device delivered using this approach. This compared to population level advice. Specifically, we want to test, to investigate the impact of on diet quality and metabolic health biomarkers. So we performed a randomized controlled trial with adults where the primary outcome was set as diet quality and the second outcome as blood biomarkers. And the participants attended a baseline visit. They were then randomized to one of the groups in the study. Those that were randomized to the personalized group were classified into the metabotypes using the statistical model and with the 4 blood biomarkers. And they received advice according to this approach. And the participants, the control group, they received a population level advice that was based on the national diet guidelines. So they attended 2 more visits, one at week 4, when they were reassessed and received more dietary advice to follow, and the final visit at week 12. So in total, they followed advice during 12 weeks. 107 participants were included in the study. 54 were randomized to the personalized group receiving advice by the metabotype approach, and 53 were randomized to the control group receiving generic advice. We had a few losses along the study, but now we are actually, the intervention is finished and we are analyzing the data. So far we have some interesting results that we are still working on this, and we hope to have this published next year. So in summary, metabotypes are very diverse too. They are very important in the early risk stratification. They are also important to identify groups of individuals with distinct response to intervention, and very promising to deliver personalized dietary advice. And as far as we know, we are the first group to investigate the metabotype concept in an intervention to deliver dietary advice, personalized dietary advice. And as I said, we hope to have our results published very soon. And yeah, so that's it. I hope that I convinced you about the potential of metabotypes in nutrition research. And I would like to thank our collaborators in the Helmholtz Century, especially Dr. Anna Riedel and Professor Jakob Hillesheim, who they worked with us in the validation of the metabotype approach, also the funding agencies CAPS that provides my scholarship, HRB and ERC for providing additional funding, and my supervisor, Professor Lorraine Brennan, and my colleagues in the research group for the support during my PhD. So that's it. Thank you for
Lovely, Elaine. Thank you.